Hey folks, looks like we have a test coming up for our IM2 Integrated Math 2 classes. This is going to be part one, so I'll probably have two, maybe three parts. We'll see how the next one goes. This one took quite a while to make yesterday, so anyway. So we're going to have questions like these. Graph each of the following functions and state the function, state the domain, range, and end behavior. Okay, so this is called an exponential function. Let me show you why here. Let me grab that. It's an exponential function because this x is in the exponent right here. Okay, so right there, if the x is in the exponent function, it's going to be either a j curve or an upside down j curve or a backwards j or a backwards upside down j. And on all of them, we, IM2 teachers, would like you to plot these points, -2, -1, 0, 1, and 2. Okay, so let's plug in -2. Okay, so there's -2. Sorry, my screen switched right there. So remember, a fraction is to a negative exponent. If we flip that fraction, this will become a positive exponent. So there it is right there. And then 2 over 1 is just 2. So 2 squared is 4, so 3 times 4 is 12. So I went to the left 2 up 12. So to the left 2, and I just kind of guesstimated right there. That would be about up 12. Okay, let's go ahead and get this guy now. Okay, all right, so let's plug in -1. So 1/2 to the -1 is the same as 2 over 1 to the +1, which is 2. So 3 times 2 is 6. So we went to the left 1 up 6. So from here to the left 1 up 6. There it is right there. All right, now when we plug in 0, anything to the 0 equals 1. So 3 times 1 is 3. So there's 0, 3 right there. Let's plug in 1. So 3 times 1/2 is 3 halves, or 1 1/2, or 1.5. Plug in 2. 3 times 1/2 squared. So 1/2 squared, where'd it go? Let's see, it's right there, is 1/4. So 3 times 1/4 is a fourth. Okay, so there's my backwards J curve right there. Okay, and then so let's talk about the domain and range and end behavior. So the domain is, it goes to the left forever, it goes to the right forever. So I'm going to say all real numbers. X equals all real numbers. The range is a Y answer. It goes up forever, but it starts down here on the x-axis. That's y equals 0. So we'll say y is greater than 0. Okay, and then end behavior, when we go to the right, that would be as x goes to infinity. This graph is going down, 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 down to 0. So as we go to the right, the graph goes to 0. And then as we go to the left, x goes to negative infinity. This graph shoots up to positive infinity. Okay, so that's everything that I've said right there. Okay. All right. Excuse me. Here's number B. I know. So let's do -2, -1, 0, 1, and 2. Okay, so 3 to the -2 power is going to be 1 over 3 to the +2, which is 1/3. And don't forget that negative, the negative's not being included with this exponent. Okay, so we're just going to square 1/3, and it's always negative. Okay, so 1 squared is 1, 3 squared is 9, so we get 1/9, and then don't forget it's -1/9, so it's going to be -0.1. Okay, so to the left 2, just down a little bit. Okay, actually that should be a negative right there. Sorry, let me throw that in there. That's a negative 1/9. So right there, that should be a negative. Right there. Okay, I'm going to lose that. Let me see if I can copy and paste that. Okay, but that's a negative right there, and it just keeps going negative, negative, negative. Okay. All right, is it going to let me? Yeah. Okay, so let's plug in the next one here. Okay, so we get -3 to the 1, which is 1 over 3 to the +1. So that's going to get me a negative 1/3, which is a -0.33333. Golly, I forgot that negative also. All right, let's just get another one going here. So that's going to, anyways, that's a negative. Okay, so because this is a negative right here. Okay, so that's a negative right there. So this is a -1/3. All right, let's do 0. So 3 to the 0 is 1, but it's going to be -1. Okay, so there's my -1. I lost my negatives right there. So anyway, it just keeps going. Don't forget that's a negative right there. That's a negative. I'm not going to be able to keep copying and pasting both of them right there. So -1, sorry. Let's do 3 to the 1. 3 to the 1 is 3, but it's going to be -3. So we'll go over 1 and then down 3. Okay, so that's going to be our next point. Over 1, down 3. 3 squared is 9, but it's -9. So over 2, down 9 right there. Okay, there's our graph right there. And then let's describe our domain. It's always all real numbers on these, you guys, because it does go to the left forever, and it goes to the right. So x is all real numbers. The range is, it goes down, so it's below the x-axis, so its y is less than 0. And then as we go to the right, that's when x goes to infinity. This graph is going down to -infinity. As we go to the left over here, then this graph is going up, 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 up to 0. So it's going close to 0. Okay, let's try this guy. Okay, so let's do the same points, -2, -1, 0, 1, and 2. So 3 to the -2 is going to be 1 over 3 to the +2. So 1 squared and 3 squared is 1/9. So we get 2 times 1/9 is 0.22222. So I'm just guesstimating right here. So I just go to the left 2 and up barely right there. Okay, let's plug in -1 now. Okay, so 3 to the -1 is going to be 1 over 3 to the +1, and 2 times 1/3 is 2/3, okay? 2/3, which is 0.6 something. Golly, I'm making all kinds of mistakes. Okay, so 0.67 or something right that. 2/3 up, okay? You saw my cheater stuff right there. Okay, anyway, so that should be a 0.7. So to the left 1, up 0.7 right there, okay? Let's keep going. Okay, so that's going to change back to that 3, but that should be 0.7 because it's 2/3. It's that right there. Sorry about that. And then so let's do 3 to the 0. So 3 to the 0 is 1, and then 2 times 1 is 2. So we'll go over 0, up 2. Okay, let's see if I can just keep changing that there. That's a 7, sorry. Okay, and then let's do 1. So 3 to the 1 is 3. 2 times 3 is 6. 3 to the 2 is 9. 2 times 9 is 18. Now I can't graph that one right there, you guys. I can't go over 2 up 18 because it would go way up here off the chart right there. Okay, so here's my graph right here. So this one's a J curve right here, and then our range is all real. Our domain is all real numbers. The range is it goes up forever, and end behavior as x goes to the right. As x goes to infinity, this graph is going up to infinity. As x goes to the left, this graph, and I tell my students it's asymptotically going towards this asymptote right here, y equals 0. So it's going towards 0. All right, now this is called a power function, you guys. It's a power function because it's a number in the exponent. So this is a parabola. This is going to be a parabola that opens down because it's negative. I like to put these guys in vertex form, you guys. So vertex form is that right there. If it's in vertex form, then the vertex is HK. And just think opposite on that. So whatever that is and that is. All right, so let's put this 6 over here. I'm going to put the 6 over there. And then the x is like x minus 0. So there I can see the vertex is at 0, 6. Okay, all right, and this guy, remember, it's going down, so it's going to go down. If I go over 1, you square it and then multiply it times 3. So it's going down 3 times 1 squared, 3 times 2 squared, 3 times 3 squared as we go over 1, 2, 3. Okay, so I didn't go over 3 and down 27 because the graph wouldn't let me, but I could go over 2 and down 12, so that's what that is. So there's the graph right there. In the domain, it goes to the left and right forever. The range is it starts way up there at 6, and we include it, so it's less than or equal to 6. And end behavior is we go to the right. So if we go to the right, this graph is going down. So that's what this says. As x goes to infinity, y goes to negative infinity. Similarly, when we go to the left, this graph goes down also to negative infinity, okay? Here's another parabola. Let's put this in vertex form, okay? So it looks like that, and so the vertex is at -1, 0, and this graph is going up, okay? So because it's positive. All right, so we go over 1, it goes up 1 squared, over 2, up 2 squared, over 3, up 3 squared, okay? So there's that parabola right there, and the domain is all real numbers, x equals, starts at 0 and goes up, so the range is y is greater than or equal to 0, and our end behavior, when we go to the right, the graph goes up, and when we go to the left, the graph goes up also, okay? Let's try another one of these. Okay, let's put this in vertex form. Subtract the 5 on both sides, and so the vertex is at 4, 5, okay? And I tell my students, think opposite. So it's x minus 4, so it's at 4. Y minus 5, it's at 5, so it's at 4, 5. This graph is going down because it's negative. It's going down. 2 times 1 squared, 2 times 2 squared, 2 times 3 squared, and so on and so on. Okay, so there it goes down right there. All right, and so there's our domain and range and end behavior. So as we go to the right, it goes down. As we go to the left, it goes down. And, whoops, I made a mistake. So the range is, sorry, I'm making lots of mistakes. The range is y is greater than, less than, or equal to, golly, less than or equal to, let me fix that. Right there, less than or equal to the y coordinate 5 right there. All right, okay, I don't see these mistakes until later. All right, this one says solve these equations and keep answers as exact values. So we want like square roots, like 5 root 7, something like that, okay? And if it's ever an x squared equals, don't forget your plus or minus part. So here, let's divide everything by 4, and then we get x squared equals 8, golly, not the square root of 8. So when we x equals the square root of 8 right there. Man, lots of mistakes this morning. Sorry, it's 5:30 in the morning and I'm at school. Got a big day today, so anyway, so x equals the square root of 8. So x squared equals that 8. Anyway, so and then break 8 down to 2 times 2 times 2. That's what I tell my students, factor trees, and so a pair of 2's come out. So don't forget your plus or minus. It's plus or minus 2 root 2. Okay, let's try the next one here. Okay, so here we're going to divide both sides by 10. So when we divide by 10, we get that, and then we're going to square root both sides. So when we square root both sides, we're going to square root the top and the bottom. The square root of 16 is 4. And then we got to get rid of that radical 10 downstairs. So to get rid of that radical 10, we multiply it by 1. That red 1 is the square root of 10 over the square root of 10. And so we get 4 root 10 over plain old 10. And then we can reduce these, you guys. I can reduce 2 goes into 4 twice. 2 goes into 10 5 times. So we get plus or minus 2 root 10 all over 5 right there. All right. Okay, let's try this guy here. So okay, we're going to get an imaginary. Remember the i's right here? So subtract 20 on both sides, and then square root, and then let's pull the I out, and then break down to 20. So 20 is 2 times 2 times 5, and then a pair of 2's come out, so plus or minus 2i root 5. Our textbook likes to write the I after the radical. And to me, it's just kind of harder to see if it's inside or outside. So sometimes they would write it, our textbook, and I'm not comfortable with that. But if your teacher wants you to do that, throw that I over here on this side after the radical sign. So plus or minus 2 root 5, and then put the I afterwards. Looks cleaner to me if we put it right there. Anyways. Okay, so divide by 5, and so when I divide by 5, I get that, and then we're going to square root. Don't forget your plus or minus right there, and then let's pull the I out on top, and then multiply it by 1 to get rid of the root 5, but our 1 is going to be root 5 over root 5. So 7 times 5 is 35, so plus or minus I root 35 all over 5. And I tell my students, if one is not in a radical and one is inside a radical, you cannot cancel those. Okay, they both got to be either insides or both outsides to cancel. So that's our answer right there. Okay. So let's do this one. So subtract 8 on both sides, and then divide by 3. And then don't forget your plus or minus when you do that. And I pulled the I out, and 8 is 2 times 2 times 3. So now we got to get rid of the radical 3 downstairs. So we'll multiply it by 1. The 1 will be root 3 over root 3. And we get that as our answer right there. Okay. All right, so part 2 will be coming up later today. Take care, you guys. Good luck on your test next week.